Hello everyone. Today we are going to talk about building a high-performance data lake analytics engine at Alibaba Cloud with Presto and Alluxio. I am Zhenlin. I am a software engineer in Alibaba Cloud. I have been in the Presto team for about 1.5 years. Right now, I'm mainly focused on the performance improvement of Presto. In this session, we will introduce the DLA product on Alibaba Cloud, and we will also introduce the DLA Presto architecture and some challenges we met, and also the optimizations on OSS data source. The Data Lake Analytics, aka DLA, is a large-scale serverless data federation service on Alibaba Cloud. Its main advantages are serverless and support for data federation with multiple data sources, and the database-like user experience and high performance. This figure shows the DLA architecture. We have one-click data lake. Users can use it to transform data from database to OSS in order to gain higher performance and less pressure to the database. We also have a metadata service to manage our metadata, and it supports auto-discovery to automatically get schema from the files without executing any DDL. And we support two kinds of analytics engine, the Spark and the Presto. Compared with the community Presto, DLA Presto have some advantages and features. For example, we support multi-coordinators to get high availability, and also we support enterprise level access control, and we also support MySQL binary protocol, so you can connect to DLA directly with a MySQL client, and also some BI tools that support MySQL. Presto supports two billing methods. We have two kinds of clusters. The default cluster is shared by all users. It is charged based on the number of bytes scanned, and we also support the exclusive cluster, which is named with CU cluster, and the CU cluster is charged based the number of computing units. So after introduction to the background, now let's see the DLA Presto architecture and the challenges we met. In DLA Presto, we have the default cluster and many CU clusters, and both default cluster and the CU cluster support various data sources. We also have a front node model. It is a service to provide MySQL protocol support. Presto is an open source distributed SQL query engine for running interactive analytics and queries. In Presto, all the processing are in memory and pipelined with stages, so it is quite fast. And also, Presto is compliant with ANSI SQL, and Presto has a storage abstract, so you can develop new data sources with pluggable connectors. And Presto has a great community. You will find it used by many well-known companies. Since DLA Presto supports various data sources, and each data source has its own problem to solve. Let's say for the OSS data source, we need to reduce the cost caused by calling OSS API, and also we need to solve the performance issues caused by the access delay and the OSS bandwidth limitation. For the max compute, we need to improve the performance because it has large data size and the network latency. And for my SQL Server, we need to reduce the pressure on data source. And for table store, we also need to improve the performance. To analyze the problems, we divide the data sources into three categories with two dimensions. One dimension is data size, and the other is the update frequency. And we found that the data sources with small data size and updated frequently, such as MySQL Redis, they are usually used in the online systems, so users care about pressure caused by Presto because they do not want to affect the online system. And for the big data sources, we found that the data source is updated frequently. They are usually called the NoSQL system, and the data source updated infrequently. They are usually used as an offline system. And for the big data systems, we need to improve the performance because the data size is very large. So, for the online system, to reduce the pressure, we limit the concurrency and avoid reading from master. And for the big data offline systems, because data is not updated frequently, so it is suitable for caching. And for the NoSQL system, what we can do is to push down to do some computation in the NoSQL system and pull less data to the calculated data. Now let's look at the fourth solutions. For the OSS data source, we decrease the request count to reduce fee, and we also use Alluxio data cache to improve performance. And for Max Computer, we use a lot of caching methods to improve performance. And for the online systems, we limit concurrency, read from slavery, and also use one-click data lake so that user can read data from OSS instead of their online systems. And for table store, we did some push down. And next, I will introduce some details on the implementations on the improvements for OSS data source. As just mentioned, I will introduce these two optimizations: decreasing OSS API request count and Alluxio data cache. When users query OSS data source by DLA, they sometimes find that the OSS calling fees are high. And the OSS calling fees are basically related with the request count, so we need to decrease the request count. Let's first see how Presto access OSS. The Presto access all the underlying file systems in Hive data source with the Hadoop file system API. For the OSS data source, we use Alluxio OSS file system. It is an open source implementation of Hadoop file system for OSS. And in the Alluxio OSS file system, the Hadoop API was translated into the OSS API. Let's look a little deeper to see how Alluxio OSS file system read from OSS. In the Alluxio OSS file system, the OSS data is read with a unit of 512 kilobytes. That means every 512 kilobytes we read, the Alluxio OSS file system will generate a request to OSS. So if the file is very large, Alluxio OSS file system will generate a lot of requests. In order to reduce the request count, we need to use one request to read as much data as possible. So here is the OSS reading process after the DLA improvement. When we read the OSS data, we will use one read request to read as much data as possible. If we read the file sequentially, that will be okay. If there is a small seq, we will translate the seq to read and skip, so it is still one request. But if there is a large seq, since we cannot read that large data because it is too slow. So we simply close the current request and start a new one. After the improvement, the request count was reduced down to 1/10 on text format and 1/3 on ORC and Parquet formats. Next, we will talk about the Alluxio data cache. When trying to use caching as an improvement, the first question is why using Alluxio data cache instead of building our own caching service? There are three reasons. The Alluxio data cache is a proven solution tested in the production environment, and also it is efficient and easy to monitor. The next question is there are two types of development to use Alluxio with Presto: the local cache and the Alluxio cluster. Which one should we use? Before answering the question, let's take a deep look on how they work. First, the local cache. In the local cache mode, Alluxio data cache is a library residing in the Presto worker, and the cache data is stored in local disk. So the Alluxio library is responsible to handle the read request. It will decide whether to read from the cache the data or from the external storage. Because data is stored in local disk and can only be read by local worker, so we need to improve affinity to get a higher cache hit ratio. So the Presto provides the soft affinity scheduling. It makes the best attempt to assign the same split to the same worker. In the figure below, it shows the process of split scheduling. We see that Presto will calculate two preferred nodes for every split, and it will try to schedule the split to the preferred nodes. And if the both preferred split if the both preferred nodes are busy, the split will be scheduled to the least busy node. And in the cluster mode, Alluxio is a distributed caching service to Presto. That means the Alluxio will be a separate process and maybe a separate cluster, and Presto can read all data from all Alluxio nodes. We finally chose the local cache. That is because in the local cache mode, data is closer to computer node, and we do not need extra nodes to deploy Alluxio. There might be another option to co-locate the Alluxio cluster and the Presto cluster together. But in the co-located cluster, the maintenance would be more complicated because you need to manage two processes, and also for the users who do not have OS as data source, the resource used by the Alluxio process would be a waste. Next, I will introduce some improvements in DLA. The community Alluxio local data cache solution was based on some assumptions. For example, it will assume that the queries are mainly on Hive data sources and the storage type in the node is SSD. Unfortunately, in DLA, both assumptions are not met. In DLA, we have different users with different scenarios, so for a specific user, we can't assume that the queries are mainly on Hive data sources. Maybe the user query a lot on MySQL, but only a few queries on OSS. So if the performance improvement is in the statistical sense, the user may not feel it. So in order to make this kind of users to feel the improvement, we need to increase the cache hit ratio for every single query as much as possible. And in DLA, we use Ultra Cloud disk, and the disk throughput is much lower than that of SSD. That would affect the cache read and write throughput, so we need to increase the cache hit ratio. Let's first review the soft affinity scheduling. As mentioned before, when preferred nodes are busy, the split would be scheduled to least busy node, which is a random node. So to increase the cache hit ratio, the key point is to submit more splits to preferred nodes. In Presto, there is a configuration, the max splits per node. We tried increasing the configuration and found that the cache hit ratio increased, but at the same time the load for workers become unbalanced. The figures in the right side shows why. In Presto, the preferred nodes were calculated based on the file path, so the splits reading same file would be submitted in same worker node. So if a file is bigger than other files, then the corresponding worker will have more splits and thus more load. So to solve the problem, we need to submit splits of a big file to different nodes. We changed the formula of calculating preferred nodes. we add the file position as a parameter, and it turns out the workloads become balanced. For the disk throughput, we tested the Ultra disk and found that the throughput is only about 100 megabytes per second. But if we use multiple disks, the throughput will be increased. So we changed the cache storage path from one disk to multiple disks. We tested the performance using TPCH. The files are stored at OSS, and we choose some queries with higher throughput from TPCH. And the test results shows that we have improved the performance by several times, especially for the Q14 and the Q15. We have more than 10 times improved. In the future, we will try Alluxio cluster because it is outside the Presto cluster, so it is suitable when Presto auto-scaling. And also, we will improve the queries for OSS data source in many other ways. For example, to backport the fragment result cache, which is already implemented by the community. And also, we will implement the query result cache, and we will improve the performance of querying small files, and maybe some other improvements. Okay, that's all for today. And if you are interested in more information about DLA, here are some links, and also we are hiring. Thank you.